Okay, so our first special right triangle that we're going to talk about is the 45, 45, 90 special right triangle. So the 45, 45, and 90 refer to the degrees of your triangle. So when you have a triangle with two 45-degree angles and a 90-degree angle, you have a special triangle. Now what makes it special is how the sides relate to one another. Because what kind of triangle is a 45, 45, 90? It's isosceles, because it has base angles congruent. And so because the base angles are congruent, that means the legs have to be the same. So we're going to call them A. And so both the legs are A. And if we were to do the Pythagorean theorem with side length A for these two legs, you would get that the hypotenuse is A root 2. And this is a pattern that works for all 45, 45, 90 triangles. And this is the pattern that we're going to be working with. So we're going to go through 5 examples, where all we're going to do is try to find side lengths given different pieces of information. And this is what we're going to be working on for our homework tonight as well, is just this one pattern and how to find different sides given different information. So on all of these, we're going to be finding x and y. So we're going to start off with these two here. So because we're going to have more than one type of special right triangle, the first thing you want to ask yourself is, do you have a 45, 45, 90 triangle? So when you look at this first example, do we have a 90-degree angle and two 45-degree angles? Yes. If you wanted to prove it to yourself, add these up and subtract from 180, and you would get that that angle is also 45. So once you're convinced to yourself that this is in fact a 45, 45, 90, I would then go and put the A's and the A root 2 on the sides they're supposed to go on. So A root 2 is always going to be the hypotenuse. So your hypotenuse is going to always equal your leg times the square root of 2. So our two legs are A, and the hypotenuse is A root 2. So in looking at how we labeled our A's, can we tell what X is? Yeah, because what's A going to equal? A is equal to 8, so what does X have to equal?
8.
It also has to be 8, because they both have to be A. What is Y going to equal? Since A is 8, we can plug 8 in for A and get 8 root 2. Okay, so if we do the same thing on the second one, which two sides are going to be A and which one's going to be A root 2? Reagan?
Y is going to be A and 25 is going to
Good, the hypotenuse is a root 2, the other two are a. So what does that help us find in terms of x and y? Reagan?
Y equals 25.
Uh-huh.
And x equals 25 square root 2.
And x is 25 square root 2. It's coming out the side of the bottom.
Okay, I actually think I've
Awesome. Go outside. Dump it. Okay. Any questions so far on just the pattern? No? Seem pretty okay? Yes, no? Okay. So then this next one is going to be an example of about as hard as it gets. So again, we're finding x and y. So, whoops, I need to add in. First question, do we have a 45, 45, 90?
Yes.
Yeah. Okay, so now go ahead and label your a's and a root 2. So which one would be a and which one would be a root 2?
X and y are a, and 19 is a square root 2.
Okay, so with this one might not be quite as easy to figure out x and y because we don't know what either of the legs are. The previous two that we had done, we knew at least one of the legs. So when all you know is the hypotenuse, we're going to take the hypotenuse and set it equal to a root 2, the piece that what it's supposed to equal in the pattern. And we're going to solve for a. So how do we solve for a? Divide both sides by the square root of 2. And this is where rationalizing has its role, because we can't have a square root in the bottom. So how do we rationalize our denominator here? Multiply top and bottom by square root 2. So when we do that, we get a is equal to 19 square root 2 over the square root of 4. What's the square root of 4? 2. So we end up with 19 square root 2 over 2. So that means a is 19 square root 2 over 2. So both x and y are 19 square root 2 over 2. So again, if you're given only the hypotenuse, like we were here, we're going to set the hypotenuse to what it's supposed to equal in the pattern and solve for a. In solving for a, we'll get the two legs. Yeah.
So like you could basically just put that to whatever the hypotenuse is, you said?
Equal to a root 2?
Yeah. But like since like wouldn't the answer be like the same, just different number?
The only thing that might be different is if you can reduce it. That might be something that's different. But yeah, pretty much. I wasn't going to tell you that quite yet. Okay. So let's try another one just to see how we're doing. So I want you to again start off by labeling a, and a root 2. So these here are our last two. So start by drawing them out and just labeling the pattern. A, and A root 2. So if we look at this one, number 4, the fourth example, which ones are A and which one is A root 2?
X and 4A.
X and 4 are A, and that would leave Y to be A root 2. So how does that help us figure out what X and Y are? So Isaiah, what's X? 4. And then Jesus, what's Y gonna be? So Y is A root 2, and we've already decided A is 4. Four root 2. Okay, the last one we have here, again, start off with labeling A's and A root 2. So which ones are A and which ones are A root 2?
X and Y are A, and 28 is A root 2.
Okay, so on this one, again, all we know is the hypotenuse. So this is going to be like the third example here. We're going to take our hypotenuse and set it equal to A root 2 and solve for A. We have to rationalize, so we multiply top and bottom by the square root of 2. So I have 28 square root 2 over the square root of 4, which will give us 28 square root 2 over 2. Now what happens here? That's different than the one before. We can simplify this one. So how do we simplify 28 root 2 over 2? We can divide these both by 2 and we get 14 root 2 as our A. So that would be what our X and Y both equal.